Dear friend, first of all, we discussed about the distance between engineering stress strain and true stress strain. So, what is engineering stress? Engineering stress, we generally know engineering stress as equal to force over area or load over area. But this is not real definition of engineering stress. The real definition is engineering stress as equal to resistance over initial area. That means S equal to R over area. What is resistance? Here we plot a block, and this block has a force, external force F. We know that the block is made by layer wise layer, and each layer has infinite molecules like this, and these molecules compresses below the second molecules, and second molecules compresses the third ones, and so on. So these molecules will be strained and resist this force, and this external force will be resisted by the internal resistance R. And if we talk about in microscopic level, then these molecules applied F1, F2 and so on. Then these internal resistance will be also applied R1, R2 and so on. So this is the external force and this is the internal resistance. At microscopic level, we conclude that the summation of external force F1, F2, F3 and so on equal to F like this, and summation of internal resistance R1 plus R2 plus R3 and so on equal to R like this. So this internal resistance equals to external force F. So hence we write F equal to R. So engineering stress as equal to resistance over initial area, or also we write F over area. So this is the engineering stress. And what is engineering strain? Engineering strain is denoted by E equal to deformation over initial length. That means E equal to L minus L naught over L naught. Here L naught is the initial length and L is the final length. So E equal to L minus L naught over L naught. This is the engineering strain. We plot a diagram for mild steel. For mild steel, first stress strain measure firstly plot on the diagram on UTM machine. Firstly we draw a diagram load over elongation. So this is the engineering stress strain diagram. here is the fracture point. So notice that on UTM machine the elongation is load and elongation diagram is plotted, and then it converted into stress and strain. This is the stress. Here load divided by area becomes stress and elongation divided by initial length becomes strain. So we plot for mild strain. This is the stress strain diagram. First we perform on UTM machine load and elongation, and then it converted into stress strain divided by load over area, elongation over initial length. This is the diagram of engineering stress and strain. Engineering stress and strain. It is so as so. What is true stress? True stress is denoted by sigma. Sigma equal to resistance over instantaneous radius, or also we write F over instantaneous radius. What is instantaneous radius? The instantaneous radius is, here we plot a block which have external force F, its initial area A1 and initial length L1. When it's elongated L1, then area will be decreases A2. L2 length increases and area decreases A2. And if we applied a compressive force F, its initial length L1 and initial area A1, then this will become this. So area will be increases A2 and length will be decreases L2. When tensile force applied, then area will be decreased and length will be little longer. And here if compressive force applied, then area will be decreased and length will be area will be increased and length will be decreased. So this is the instantaneous area. So what is true strain? It is denoted by epsilon. So true strain is also a name known as other name natural strain or logarithmic strain. It is noted that logarithmic strain. So we define the true strain epsilon equal to integration L naught to L del L by L, and ln L naught to L, that means ln L by L naught. So epsilon equal to ln L by L naught. This is the initial length and this is the final length. So this formula is applicable, and we know engineering strain E equal to L minus L naught over L naught. That means L by L naught minus 1, and this value E plus 1 equal to L over L naught. we take both side log. So ln E plus 1 equal to ln L over L naught is taken by here. So this is the first equation. I input this equation. So epsilon equal to ln E plus 1. This is the very important formula for GATE, PSUs and other engineering exams. And we know that volume constancy, initial volume equal to final volume. That means area into length will become volume. So L by L naught equal to A naught by A. So for circular bar, pi by 4 d naught square divided by pi by 4 d square, this will be cancelled, d naught by d whole square. This value put in the first equation. So epsilon equal to ln L by L naught equal to ln A naught by A equal to ln D naught by D whole square equal to 2 ln D naught by D. This is the second one formula. And we distinguish between stress strain diagram. So here it is the engineering strains and true strain. Here it is the engineering stress and engineering true stress. So this is the true engineering stress strain curve for mild steel, and this is the true stress strain curve. True stress strain is longer as compared to the engineering stress strain curve. So this is the difference. Also we put some example practically. First, if we take a block L1 and this will be elongated, it's twice its initial length, that means L2 equal to 2L1. So this will become equivalent to in compression as like this, that means L2 equal to L1 divided by 2. So this experimental will be performed, and then true strain in tensile equal to 0.69 and true strain in compression equal to negative 0.69, but engineering strain in compression equal to 1 and engineering strain in tensile equal to 1 and compression equal to negative 0.5. This is the different value. Thank you.